And similarly, different other questions will be actually asked, um, indicated by examination from this particular section, right? We have already discussed some of the concepts of this TCP/IP protocol, right? And also there are other protocols like ARP, DSCP, and ICMP. ARP is Address Resolution Protocol. What it does in brief is that it converts from one sort of address to different sort of address. One is actually physical address, which is actually the MAC address, right? And another is actually the IP, Internet Protocol, right? IP address of the particular system. So what happens is that the MAC address is actually the permanent address, right? And this is actually a temporary one which changes based on the network. If you change the network, then IP will be changed, right? So what this address resolution protocol does is that it tries to find out that it tries to provide a particular address towards a particular physical address, right? And dynamic host configuration protocol actually does the opposite of in the similar fashion, dynamic host configuration protocol actually has a dynamic host which configures a particular network entity for which is actually requesting the particular server for the address assignment. I will actually cover this in detail in the later sessions, right? And ICMP is Internet Control Message Protocol. What it does is that it gives out the error messages, right, and signals over the net, which signals about the jamming or possibly an error over the network, something like that. And warning and error messages are actually sent, and they might ask you that what is the size of the segment which is actually being transferred over the ICMP, and also the questions like it also has some intermediate parts, right? This ICMP protocol has intermediate parts and the ways it actually works. So they can ask the questions regarding to that. Then you have the network translation, address translation. Then you have the transport layer, flow control, congestion control. You must know what a flow control is and what the congestion control and how it is done. Flow control is what when you have a fast sending sender and you have a slow receiver, right? So it actually just accepts this much and is actually sending this much, right? So what it actually does is it buffers the things up, right? So what a sender does is actually adds unnecessary packets, right, which is there to be wasted, so that the receiver can discard the extra packets, and the extra packets will be this one, so the only the non-useful information could be discarded. This is one approach towards the flow control, right? When a fast sending sender is actually sending towards a slow receiving receiver, and the receiver just discards the packet which are actually not required by the system. And in similar fashion, we have different protocols and techniques to actually work around with the congestion and also flow, right? And also out of order packets, right? So congestion is nothing but when you have everything up, like a lot of traffic over the network, right? And how do we actually control this traffic, right? By what algorithms do we actually do that? So you have different sort of techniques for this. UDP we have already talked about. Fast one, TCP is connection oriented, UTP is connection less. Sometimes there will be differences based question, right? Means like they will give points and you will be actually need to match different things up, like connection oriented to say TCP, connection less to this one, retransmission of packet to this one, something like that. Matching, anything could be there. They will try to confuse you by providing a matching table, but essentially you will actually need to learn the functionalities of these two protocols, where they are used. Then you have the sockets, right? So sockets are nothing but ports through which two particular entities actually communicate, right? So basically what happens is that they will ask you different steps of sockets, right? How the server actually creates a particular port for listening, how the client actually connects for this, and what are the methods which they actually use from the client side, right? Client side to server side, right? The server might be listening on a particular port and will be actually activating a particular port for listening. The client will be actually sending a particular request to connect to this particular port, and then the data transfer would be happening. Apart from that, there will be also another question on the TCP handshake, right? So there will be another question with the TCP handshake, that how the TCP handshake actually happens. You have, say, firstly the SYN bit, right, synchronized bit to be on, and then you have the SYN plus acknowledge, right? And then you have the acknowledgement, right? So how it works we can actually discuss in later part of video, but this is a three-way handshake, and you must know that what acknowledgement number goes from here to here, or sequence number goes from here to here, and how the acknowledgement number comes from here to here. In general, the acknowledgement number is equals to sequence number plus 1. So essentially whatever the sequence number which came, the acknowledgement number is actually 1 plus than that, means it is actually the number which is the next byte which is expected, and the sequence number is actually the next byte which is sent currently, right? So they both have their sequence number from here to here, and they both have their acknowledgement number if the acknowledgement bit is 1 and if the particular entity is trying to send the acknowledgements. Apart from it, another question actually comes from the email, right? How to actually receive and send the emails, right? So for sending the emails you have SMTP, right? Simple mail transfer protocol is there to send the mail, right? But for receiving the mails, right, you have different protocol like POP3, right? That's actually keeps on checking the particular server, right, that whether the mail comes, because the mail doesn't come directly on your system. They first comes on this server, then on your phone, that actually synchronizes with particular system. Because if your device is actually offline, right, you have not the internet, right, you don't have the particular connection, then what will happen is that your emails will get lost. So what happens is that they actually get saved into this particular big entity, that is server, and then they actually syncs with your mobile device. That's what happens in the general scenario. So there are two types of protocols which are covering under the emails. One is actually POP3 and one is SNMP, right? So basically one of these protocol is actually deleting the messages, right, just after downloading from server, but another protocol is actually keeping the things over the server for a stipulated time, so that the same email, right, can be synchronized over your mobile and can be synchronized over your tablet, can be over your desktop, right? Because if you actually just read once and then delete it, then it won't be synchronized over these devices. So that's why upgraded version actually came from the earlier version of this particular protocol to actually synchronize the things over different entities, just on the cost of the space which they are actually providing from the server for a stipulated amount of time. Okay, so we have covered a lot from this unit, right, and most of these questions actually come from this one only, right, that how this works. Another question which actually I have seen sometimes also is actually from Hamming, right? Basically how Hamming code works, and how many bit errors actually Hamming code is expected to correct. So basically Hamming code doesn't work on multiple bit errors as per as book, right? So what happens is that you actually add redundant bits. So there is a famous formula which is again and again asked into the exams, like 2 to the power r is greater than m plus r plus 1. So m is actually the message size, how many bits are there into your message. R is the redundant bit which you must add into this message and add it with 1, right, for the upper bound, right? So basically you have to satisfy this particular equation to find the r value, that is how many redundant bit you want to add. For example, if I have say 7 message bits, right, 7 bit message, or say 8 bit message I have. So what I will do is that I will try with 3. So 2 to the power 3 is greater than equal to 8 plus 3 plus 1. Is it so? 8 is greater than equal to 8 plus 3 plus 1. That's actually 8 is greater than equal to 12. That's actually wrong. So we must try for more value, more redundant bit. So 2 to the power 4 is greater than 8 plus 4 plus 1. So that actually becomes 16 plus 8 and 12. 13, right? 16 is greater than equal to 13, right? So that's actually whole, so it means r is equals to 4, and that's again and again asked into the exams. That's how you find how many redundant bit you actually add into your message bits. So then after that what you will do is that you will actually make positions into your message, right? Like you will actually go for 2 to the power 0. For example, you have to add 4 bits, right? So it will be r0, r1, r2, r3, right? 4 bits. So basically you will actually add to this place r to the power 1, right, and then r to the power 2, right? So that's actually will be here, right? So that's actually 1, 2, 3 and 4. So fourth position will be somewhere here, and then r to the power 3, to the power 3 will actually be here, be at 8th place. So 5, 6, 7, 8. So there you will have this to the power 3 r, or I must say r naught, R1, R2, R3 redundant bit. Then what you will do is actually take all the places in which the zeroth bit is active. For example, to make a value of 1, you will need this bit. To make a value of 3, you will need this one, so this bit is required. For to make a value of 5, you must require this bit. So for all those particular values or positions on which this particular bit is required, R0 will be there. So you will just do XOR of all these ones, right? And then you will actually just stipulate on whether you are actually going for even parity or odd parity. So for example, you have 1/3 and 5th bit to be 1, 1 and 1, then all XOR will actually come out to be 1. And if you are actually keeping it to be even parity, then it will be plus 1 more to actually keep it to be even, right? Plus 1 more to keep it to be 0, right? The XOR will be 0 and that comes out to be even, right? So I'm actually just telling you it in a bit of abstract, right? This Hamming code working, but a detailed example could be worked out if you actually just come in for the one. What will happen is that we will actually keep our R0 to be 1 to have our even parity, right, satisfied. Similarly, we will actually calculate for R1, R2 and R3, right? Or I will check for all those position other than these redundant bits on which the particular third bit, or I must say 1, 2, 3, fourth bit is actually useful and used to actually calculate for that particular position. And then I will see what the value is. I will try XORing all, and if I am actually keeping it even, I will see whether it's already 0. I will not add anything. I will actually keep it 0, and if it's actually 1, I must add 1 to actually make it an even parity. So I will actually make R3 to be 1. Right, at the receiver side, again this whole process is actually calculated, right? And they all, if actually at the end I'm actually getting 101, then it means that 5th bit is actually flipped, and I will actually again flip the bit. If it's 0, I will actually flip it to 1. If it's 1, I will flip it to 0 to actually make it correct. So it's able to detect and correct 1-bit error, and that's what Hamming code is. That's actually usually asked. Apart from that, you must also know which devices work on which layer. For example, there is bridge, right? Which layer it actually works. You must know it actually works on data link layer. You will be asked that a repeater works on which layers. It actually works on the physical layer, right? You might be asked for switch, which layer it actually works. This is also on the lower layer, right? Similarly, you will be asked router. It works on which layer? It actually works on network layer, right? Because network routing actually happens at this layer, right? Similarly, you will be asked different devices that whether what device actually works on which layer. So you will actually remember, if you remember some, right, you will be actually able to do most of the questions, right? Because many of those questions will be actually in the matching phase. So if you can actually match many of the options and just only one is left, then it will be automatically matched, right? So you can actually follow this way also. So that's all today for, I think it's a lot already, right? Discussing the detailed syllabus of this GATE 2026, and if you prepare this way and if you try to tackle the questions directly of this GATE 2026, then I believe you can definitely crack this GATE and also GRF and also NET with any possibility of the examination and in any possibility of the papers at which they are actually keeping out. So thank you so much guys for watching, and just leave some suggestions how we can actually proceed further, what are the sessions which are required. Hit like, subscribe, and thanks so much for watching again.